Hello everybody. Today we are going with audio excursions. This is a new series that I'm going to be working on where I'll be going through different audio based machine learning models and how you can start using those for your use cases. We will focus on use case based. So we'll start with a use case and we'll try to identify the best in class model or whatever is available out right now based upon our requirements, and we'll try to identify how we can start using that for our use cases. First video in this series is speech to text, and we will try to identify how can we build a API endpoint or a function that we can use for generating text from a speech. So some of the must-haves that we are looking for in this example is we want a model that can give us high accuracy. So we are not trying to do this online on server as things are happening or in real time. We are going for a file that already exists. We have done the recording, and we are trying to get the highest accuracy possible transcript out of that recording. We also want this free to use. You could use APIs that are available. They might be limited for free to use APIs. They might have limitations on like 30-second or only a small set of audio, only a number of audios that you can do. But we want a totally free to use sample in here. Another thing that we really want is an offline first. So in this case, what we would want to do is, rather than relying on API that a provider has, we would want to have the complete model that we could run locally and get the actual response output on our local machine without having to send the audio files to any server. And of course, we would also be looking for a multilingual support. That'd be really useful if you could have audio from different languages, pass it along into the model, and get the output back in English. So we are not going for the output multilingual support, we are going for input multilingual support in this example at least. So one of the best models that has come out for this is OpenAI's Whisper. It's been around for a bit. One of the best things around it is it comes in multiple various sizes, and for our use case we'll stay focused on the large one because we are trying to go for the best accuracy. We are not limiting that, so we'll go for the biggest model, the best thing that is available out there. It's multilingual by default, so you don't have to worry about using a smaller model or worrying about languages in here. Its size is something that you need to worry about. So you have to have at least this much available VRAM available, and it's going to be fairly slow. But as I mentioned, we are trying to go for a local first use case where speed and everything else is not our concern. We are only focused on these 4 must-haves. One of the good things about Whisper model is most of the paper is actually available online, so you can take a look at how exactly the model was trained, and you can also look at how did the team work towards reducing the error rates, and how does the dataset perform across different open available datasets that are out there. How does the model perform across open available datasets? So how do we get started with this? I built a small fast API sample in here where I want to, whenever I build something like this, I want to always capture the amount of time that it takes to process this. And we have a sample endpoint in here. I'm just calling it 1 because this is the first video, and we will try to transcribe the audio in here. Just to go back in here, we are only looking for audio path because we are assuming that the file is locally present wherever this API server is running. I'm calling it API server, but don't assume that it's running anywhere. You can run this API server on a local machine. So in this example, it will be running on my local machine, and we will be transcribing an audio. We'll pass an local path. How does it work? So here's a few things that we have to load in here. We are using Torch in here to figure out if there's a CUDA device available. CUDA devices, NVIDIA's GPU support this CUDA API, and with that you can take a look at like if the device is available, we'll be using that. Otherwise, we'll be falling back to the CPU. Fairly simple way to just start using CUDA devices right here. Then we'll be loading the Whisper model, and in this case we are going for the large model, and we are loading it to the device. So it will automatically figure out if we have a CUDA device, we'll be loading it to the GPU, otherwise loading it to the CPU. On my local machine, it's a Mac M1, I think M3, and on that we don't have a GPU available, at least not the one that's supported by CUDA. So in this case, we'll be falling back to the CPU. Once the model is loaded, we are doing this. Just a thing to note is we are doing this whole model loading before the actual function call. This is the function that is being used inside our API endpoint, but we are loading the model as our server will be loading in. This allows us to keep the model into the memory, and anytime a request comes in, we don't have to reload the model or worry about any loading or the slow load on the first call. by doing this, moving our model load code outside of the API endpoint, we reduce that time. Okay, so how do you start doing this? We just get the path of the audio, we pass it in here, we pass it along with it that we want the word timestamps to be available and the temperature. The model in the back on its own is using FFmpeg, which is an open source package that a lot of people, it's like one of the standard packages out there anytime you want to mess around with audio. And it uses that package in the background along with the model itself to generate the transcripts. Now these transcripts are generated in segments, and we use these segments to generate our transcript.csv file, and essentially we get the start and the actual text value that we wanted. Now if you wanted to convert this from rather than a CSV into a SRT file or a complete text file, you just need to modify the function that is in here and you can convert it into different formats. But the whole response is available to you in result.segments in here. So let's see how this works. So here's the curl request that ends up being localhost 8000 and then 1. That's the endpoint that I have, and I passed in the audio path. I have this Gettysburg file, which is Gettysburg address by JFK. I think it's a 16 or 17 second file that I have. And here's our server running. It loads the file, it performs the whole operation. You see that it's running on the CPU, and FP16 is not supported, so it goes to 32. And of course it runs the whole process, and it takes 29 seconds in here to perform this transcript. This 29 seconds for 16-second audio or 17-second audio is not great. So we want to get to a better response, and the way to do that would be run this on a server or a place where you have GPUs available. So for that, I go to this Colab, which is on Colab Pro specifically. I have GPUs available, and in this case, we are using a T4 GPU, which has a lot of RAM in here, and we can use this to perform the same process again. How do we do this? We just install the same again, install Whisper, and remember to install it using Git, otherwise you might just get stuck into some random package. After installing Whisper, we just import all the packages, same process again, but this time our device actually has a GPU available, and we download the model. So this is 2.8 gigs of model that is being downloaded in here, and then load it to the GPU device. Then the function remains same. In this case, I've just added some smart start and end times in here just so I can have a log in here to see how much time it takes. All the files are available here. I have put Gettysburg wave sample in here, and I've also added a Hindi language just to test how does the model perform from Hindi audio and converting it into text. So here's the sample. We run the model, and it takes 5 seconds to generate the transcript, and here's the transcript. You can see start and end text values in here. We also run the Hindi one. I think it's a 1 minute some long video or long audio, and then we convert it into transcript as well, and here's the transcript. I'm really glad that Colab actually supports Hindi characters in here, so I don't have to worry about how will it show or not. And actually it's doing a really good job. I listened to the audio, I'm a native Hindi speaker, and this is really good output in here. Just to clarify, the audio is actually fairly normal-ish and like very well recorded audio. There's not a lot of background noise, but for the sample that we are going for in here, speech to text, this works really well. So what's next in here? So on next, we should look into a few things that are missing in here. First is Whisper model hallucinates a lot. So what you could do is you could upload a video of just background noise or just silence, and it does really hard work to trying to figure out what is being said, and it might hallucinate and give you random text values in here. So that's something that is tunable in the API itself, so you can pass in some parameters around. I don't remember the exact value, but you can pass in some parameters and try to tune around hallucination. The second thing is this is trained on publicly available data or whatever data OpenAI has access to. But if you have examples or use cases where you are using your own terminology, let's say you work in highly specific domain in some industry, then OpenAI Whisper model might not be able to get those specific terms properly. So what you might want to do is you can take the model and retrain it for your own use case. And then the third thing that I feel like is generally fairly important is diarization, which essentially means that when there are multiple speakers, how do you classify the voice to speaker 1 versus speaker 2? and same on the text itself. So how do you make sure that the speaker 1 is identified, all of the things that they are saying gets assigned to them, and speaker 2, speaker 3, and onwards. So those are the things that we will try to explore in our next future models, future videos in here. Yeah, looking forward to it. Thank you so much, and like and subscribe. See ya.